Okay, so what we're being asked to do here is to solve. So on this particular one, we want to solve this one by converting it to an exponential. And what that's going to do is that's going to get the variable outside of the parentheses portion of the log. So we take our base, which is 6, we raise it to our exponent, and we set it equal to what's inside of the parentheses. So now what we got to do is to evaluate what 6 raised to the third is. So 6 raised to the third would be 216. So that's what x is equal to here. Okay, so for number 12, we're going to work it the same way we did number 11. We want to take it and we want to convert it to an exponential, because that's going to get the x out of the parentheses portion of this. So we take our base, which is 36 here. We raise it to our exponent, which is 0.5. And we set it equal to what's inside the parentheses. So here, if we raise 36 raised to the 0.5 power, that gives us 6. So 6 is equal to x. Okay, so 13 is going to be worked just like numbers 11 and 12. We're going to convert it to an exponential, and we're going to get the x part out of the parentheses that way. So we take our base, which is 2, we raise it to our exponent, which is 9, and we set it equal to what's inside the parentheses. So all we have to do now is to evaluate what 2 raised to the 9th power is, which is 512. Okay, so 14's worked a little bit differently because we have two logs equal to one another. So we're going to use this property where if we have log base b of x and it's set equal to log base b of y, then what we can do is, since we are log with the same base, we can ignore, basically that, we can think of it like canceling out. It doesn't really, but you can kind of ignore the log in the base, and you can set x equal to y. So as long as your bases are the same, then you can just look at what's inside the parentheses here. So for 14, we have log base 4 of 2x plus 5 equals log base 4 of 4x minus 3. Since we have log base 4, we can ignore the log portion of it and set the inside part of the parentheses equal to one another. So now this becomes pretty much like an Algebra 1 problem. So we want to get our variables on one side. So I'm going to move my variable x to the right. I'm going to subtract 2x from both sides. So we get 5 equals 2x minus 3. And then we want to get x by itself. So we're going to add 3. So we get 8 equals 2x. And then divide both sides by 2. So we get 4 is equal to x. Okay, number 15, we have log base 8 of 2x equals log base 8 of 6x minus 8. So again, here we have logs with the same base, log base 8, so we can ignore the log base 8 part. And we can set what's inside the parentheses equal to one another. So we want to move our variables to one side. So I'm going to move the 6x over to the left since we don't have any constants over here. So that becomes negative 4x equals negative 8. And then we're going to divide both sides by negative 4. So that cancels. We're left with x. And then that would be 2. Okay, number 16, same thing. We have log base 9 of 3x plus 8 equals log base 9 of x squared plus x. So we have the same bases with the log, so we can ignore that portion of it. So we can set what's inside the parentheses equal to one another. Now this one's a little bit different because we have this square here. So what we're going to have to do on this one is we're going to have to solve this one like we would a quadratic. So we want to get everything on the same side of the equal sign. So I'm going to subtract 3x and 8 to move everything on to the left. Sorry, the right side. So over here, that cancels, so we're left with 0. And over here we have x squared. That adds up to negative 2x. And that's negative 3. So what we want to do is we want to solve this by factoring. So we're looking for two numbers that multiply to give us negative 8. That when you add them together, it gives us negative 2. Now the only way to multiply to give us a negative is to multiply a positive and a negative. So we want the larger number to have the negative because our middle term's negative. So if we think about numbers that multiply to give us 8, that when we subtract them because our two signs are different, they add up to negative 2. So that would be negative 4 and positive 2. So we have x minus 4 and x plus 2. So there is one extra step now. Now what we're going to do is we're going to take each of these factors, x plus 2 and x minus 4. We want to set each of them equal to 0 and solve. So here we subtract 2. We get x equals negative 2. And here we add 4. So we get x equals 4. Now on these we do have to check our answers because the inside part of the logarithm cannot be negative. So we need to go back in and plug our answers in to make sure it doesn't make it negative. So if we plug in negative 2 here, 3 times negative 2 is negative 6, plus 8 would be positive 2. So that's okay, because it all ends up being positive. Here, negative 2 squared would be 4, plus negative 2 would be positive 2. So negative 2 actually works out. And then if we plugged in 4, 3 times 4 is 12, plus 8 would be 20. And then here, 4 squared is 16, plus 4 is 20 as well. So that checks out.